graphs that last semester I started with my students trying to make sure they knew all of these. Now, you might not recognize all of these, but guys, we need to go through and at least mention them. So if they were to show up on the EOCT, we at least can say we have seen them and know kind of how to move them around, how to change them from the standard form of an equation to standard form of a function, and what it means to have a function equation. All right. We all started out last year, or this year at the beginning of the first semester, the first time that we graphed with this one right here, y equals x. Y equals x, an example of a point that's on the line, y equals x, is like 1, 1, 2, 2, 3, 3, 4, 4. In other words, those points, negative 5, negative 5, negative 4, negative 4. In other words, the points where y is the same as x. It equals x. Okay, if you took x and squared it, that gave you this, y equals x squared. And her term for this thing was a parabola. This picture is a parabola. Just like when you graph a linear equation, it makes a line. When you graph, listen to how I say this, when you graph a quadratic equation, it makes a parabola. That's kind of weird, but guys, that's the way the words work in math. When you graph a linear equation, it makes a line. That makes logical sense to me. When you graph a quadratic equation, though, it doesn't make a quadratic. We don't call this picture a quadratic, we call it a parabola. It's just a different one. As mathematicians, when we talk about the equation, when we talk about 3x squared plus 7x minus 8, that's called a quadratic equation. Okay, it has a little x squared in it, quadratic. When we talk about the picture, you may hear me refer to this as a parabolic function, if it's the picture. But the quadratic function, if I'm talking about the equation. You started to say something? Quadratic?
Like that, I get it's called.
Okay, I'm not real sure the origin of it, but I know why this x squared is called a quadratic equation, and you'll get more of this next year, is because there's 4 terms. There's 4 terms here that you multiply together to give you this thing. That's why x squared is called a quadratic equation, because of the 4 terms. I don't know if you've ever heard of the FOIL method of multiplying stuff out before. Okay, but FOIL becomes parabolas, and I'm not sure, to be honest with you. Here, this is, you'd be a major mathematical stud if you knew what that little S right there was.
X cubed.
Yeah, y equals x cubed. Very good. And yes, the next one is a square root. Okay, again, guys, if I wanted to take any of these things and change them from a cubic equation or a square root equation to a square root function, remember, I would take out y and plug in f of x. F of x. Guys, look, this says y equals, it's called a linear equation. If instead I said f of x equals, now it's a linear function. This is a quadratic equation. If I took that out and said g of x equals x squared, now it's called a quadratic function. Y equals x cubed. H of x equals x cubed. Now it's a cubic function. Is a cubic equation a function? Yes. Is it 1-to-1? Yes. This is a major mathematical study for you, this one. No, but I like how you're thinking right there. It's called a rational expression. A rational expression is y equals 1 over x. The infinity part that she was talking about is this little section right in here. Think about this for a second. This line that I just put through the middle right there is a place where x doesn't have a value on that dotted line. Can you look at this little fraction right here, 1 over x, and tell me what this dotted line represents? It represents the place where x is what value? 0. Can x be 0 in a rational function? No, it can't be 0 because it can't have a 0 underneath. So that's why that has a vertical asymptote. You'll get that as we progress through. As an algebra student, you should be able to look at that picture and know it's y equals 1 over x. You guys said this one, y equals the absolute value of x. Y equals a times b to the x for either one of these, with one of the two being an exponential growth and one of the two being an exponential decay. Do you remember which was which?
The one that's pointing negative is decay.
So which one's pointing negative?
That one's the last one pointing negative. No, the first one positive, second one is negative.
The first one is the one that's an exponential growth. This one's an exponential growth, which means the base b is greater than 1. The second one is an exponential decay, again, which means the base is between 0 and 1. As I tried several times last week to explain to you, remember, in exponential equations, never is the base negative. As the base is always positive. Even if I wrote something like y equals negative 2 to the x, that would be a multiplier of negative 1 times 2 to the x. Well, if I had a multiplier of negative 1 times 2 to the x, all I would have would be an exponential growth that got flipped, because that's what negatives do. Now, down here at the bottom, look at this. What if you just wrote f of x or g of x, and what that would mean in terms of moving the graph around? That's right. If I said I wanted you to take f of x minus 3 plus 2 and graph it, what it does to the graph was, this is very important. And this is the one that I'm not sure we all have seen a bunch. See how this has a minus 3 right there inside the parentheses? That means whatever that picture is, it gets moved the opposite. This minus 3 could be a parabola, it could be a cubic equation, it could be a square root equation, it could be anything, but what I'm trying to get you to see is it's inside the parentheses, and that h moves it right or left, but it moves it the opposite direction. It's the opposite of what you might think. In other words, a negative moves it to the right, and a positive moves it to the left. Now, k, the number outside, doesn't matter. That moves it up or down, and it's positive and negative in the same direction. See if you can see what I'm talking about. I'm going down here, and I'm going to open a program called TI Interactive, which, by the way, you can't use these, guys. You cannot use TI calculators on the EOCT because of this idea I'm about to show you. Look, if I took a picture and I said absolute value of, let's say, x minus 3. Today, I'm trying to get you to see that the absolute value, guys, the absolute value makes it a v, but the minus 3, while you might think it moves it to the left 3 because it's negative, guys, look down here at the picture. See what happened to the picture? It moves it right. Minus 6. See, it moves it right 6. And it doesn't matter whether that's an absolute value or whether it's an exponential equation. It still moves it right 6. I can make a cubic equation out of it. It's still going to be that S-looking picture over right 6. So plus 7, even though it's positive, and you might think that moves it to the right 7, because it's in the parentheses, it's to the left 7. the number inside the parentheses with it moves it in the opposite direction. Now, if I put a number outside of the parentheses, if I put a number outside of it, then it just goes the direction that you would think it would go in. If I say minus 5, that moves it down 5. Plus 7, that moves it up. Whoa! Plus 7, it moves it up 7. Okay, so it's only the one that's inside the parentheses.
Well, how is it going? Like, why does it?
Okay, that's a great question. See if you can like visualize this. Remember now what the picture is. Is the picture the value of x, or is the picture the value of y? It's the value of y. The picture. The blue line that you see right there is a picture of the range. So if I were to ask you to look at this picture right here and describe the range, look up here. You guys that aren't looking, look. If I said describe the range of this picture would be y is greater than 0. Because that blue line is all above 0. That's what the blue line is it's the y values. Now the x values are the numbers that you plug into the equation. So what is the number that you plug into this equation to get it back to 0? Well, that would be a positive 3. Because what's 3 minus 3? 0. What's the absolute value of 0? So look, the point positive 3, 0 is right here. And so the only way to get that positive 3, 0 to right there is if the values that you plug into the equation are the opposite of what you need them to be. And then the plus 6 would move this picture up 6, because what causes something to move up and down? The x values or the y values? The y values. Remember, the y-axis is the vertical axis. So when I'm changing something here, look, if I'm giving you the coordinates in my head right here, and I'm taking my head and I'm moving it up higher and higher and higher and higher and higher. My head keeps going up higher and higher and higher. Because the x value isn't changing. It's the y value that's changing. If I have this 4 right here, if I'm changing my horizontal position on the floor, it's x that's changing, because the y value, y equals 0 to the floor, is not going anywhere. What's changing is where I'm at. Remember, what's the definition of slope? Definition: rise over run. And the way you find the rise is by changing y. So the y goes on top. So it's rise over